All right, this is going over the force work and power test that for Chippewa Advanced Earth Science. I'll be showing you version Newton worked out results, but then also give you the results for the other version, the Joule version, the numerical results. The process is the same for both tests. Excuse me. Right. For number one, it's putting straightforward our definition of the force, which is mass times acceleration, in this case 0.3 kilograms. We need to convert grams to kilograms when we do these problems because of the definitions. You can see your notes from the first day. So 0.3 kilograms times 9.8 meters per second squared gives you 2.94 kilogram meters per second squared, which is also called a Newton. For the work, you take the force, the 2.94 newtons, multiply that by the distance, and you get 3.234. Excuse me for the announcements.
Hope you all have a wonderful weekend and enjoy your day off tomorrow.
You,
Bus 69, get on it.
you get 3.24 joules, which is also a Newton times a meter. Then the power, which is defined as work divided by time, you take the work, the 3.234 joules, divide it by 12.7 seconds, and you get 0.25 watts. Now, in the other version on the test, it's the same process, but you ended up with 2.45 newtons, 2.70 watts, and 0.21 watts. Moving on to number two. I'm going to use this other sheet I had worked out here. So, we're asked for finding the mass, which we have to find from the force equation, but we don't have enough information. So if we look at the information we're given, we can see that we have two of the three terms for the power equation. That's power equals work over time. We know the power is 0.52 watts. Time is 12 seconds. So we can solve for work and find out that the work is 0.52 watts times 12 seconds equals the 6.24 joules. That's our first step. Now we rearrange, going over how you rearrange that equation. So power is equal to work over time, but we're looking for work. So we have to isolate for work. To do that, we multiply both sides by time, and time divides out, and we're left with time times power equals work. That's how I got that equation. It's the same as A equals B over C. We're solving for C, so you have to multiply both sides by C, and you get C times A equals B. It's the same process. Second step in this problem, now that we have work, is to use the work equals force times distance so that we can figure out what the force is. So work is 6.24 joules. That's equal to the force times the 1.2 meters. Or the force then is equal to 6.24 joules divided by 1.2 meters. And that's equal to 5.2 newtons. The way that equation works, we were solving for the force. We know the work and the distance. So we divide this side by distance and this side by distance. And we get force is equal to work divided by distance, which is what we have right here. And now we're ready. We've got enough information to find the mass. The force equation is force equals mass times acceleration. And we've got the 5.2 newtons for force. Acceleration is always 9.8 meters per second squared with these water wheels because we're lifting against gravity. And so it's the 5, we're rearranging the equation, isolating for mass. We get mass is equal to the force, 5.2 newtons, divided by the acceleration, 9.8 meters per second. And when you get those, when you do the math, you get 0.531 kilograms. If you divide out all the units that are inside, these derived units, you'll see that it's kilograms. The question asked you to give the answer in grams. 0.531 kilograms is 531 grams. And in the Joule version, same process, except you end up with the work is 6.8 joules. The force is 5.68 newtons. And so then the mass is 5.68 divided by 9.8 meters per second squared gives you 0.580 kilograms. And again, you have to multiply that by 1,000 to get the answer in grams. I'm going to pause the recording and make a separate one for the last equation.